10.2, rational numbers as exponents. So this first one, we want to go ahead and take this exponential notation expression and write it in radical notation. So remember, the denominator always gives us the index, basically the root that we are looking for, and the numerator is basically the exponent of the expression. So this we can go ahead and write as the fourth root of 16. Now remember, this numerator can be written in two ways. We can go ahead and raise this entire expression to the power of 3, or I can also write it like this. So we're going to go ahead and see which seems easier to simplify if possible. Now, in this one, 16 to the power of 3 would be quite a large number. But if you look here, we're looking for the fourth root of 16 and then raising it to the power of 3. Well, does 16 have a fourth root? Yes, it does. 2. 2 times 2 times 2 times 2 is 16. So this simply is 2 and then raised to the power of 3 gives us 8. So sometimes it's easier to look at it in this form, and sometimes it's easier to look at it in this form. In this one, we want to go ahead and write this in radical notation again. So remember, the denominator is our root. So we want the cube root of 125a. Now, I can put the power of 2 on the inside, which would mean I'd have to put parentheses, or I can put it on the outside. Now let's simplify this. So once again, if you look at this, does 125 have a cube root? Yes, it does, 5. So we can go ahead and bring the 5 out, but does a have a cube root? No, it does not. So we can bring the 5 out, cube root of a, and then this whole thing squared. And now we can actually simplify this individually. 5, there's 2 factors here. Each factor needs to be raised to the power of 2. So 5 to the power of 2 is 25. And now, if I take the cube root of a and square it, I can actually take that power of 2 on the inside, just like how this power can go on the inside. So that would be the cube root of a squared. This one I want to write in exponential notation. So you take your expression, your radicand. Remember, the exponent of the expression itself is the numerator, and the index is the denominator. Same thing here. Here, the entire radicand is an expression with multiple variables and a number, so we'll go ahead and put parentheses, and this will be to the power of, remember, this is our numerator because the whole expression is being raised to the power of 5, and then it'll be over 7, which is our index. Okay, here we want to simplify this expression. So remember, simplifying means if you have the same variable, you want to use your law of exponents to combine, and then your final answer should never have a negative exponent unless you're dealing with scientific notation. So here we're going to use our product rule. The product rule states if 2 expressions with the same base are being multiplied, you could simply add their exponents together. So this will be x to the power of 2/3 plus negative 1/2. So we'll go ahead and find a common denominator, which will be 6. So I'll go ahead and multiply 2 here and 3 to this one. So that gives us x to the power of 4 minus 3 over 6, which is x to the power of 1 over 6. Okay, and we didn't end up with a negative. If we did end up with a negative, remember what would happen? Oops, sorry. If we did, it would end up going in the denominator. We want to simplify this expression. So one thing to remember, if you're not specifically told to write your answer in a specific form, then you want your final expression to be of the same form as the original problem. So if you're trying to simplify a radical problem, then you want to make sure your final answer is also in radical form. So the steps to do that would be, we can rewrite this in exponent form, simplify using laws of exponents, and then rewrite in radical form. So this would be x to the power of 5 over 30, which we can see this fraction can be simplified to x to the power of 1 over 6. And now we can go ahead and rewrite this in radical form. So the root we are in, our index will be 6 of 6th root of x. Okay, look at this one. This one looks interesting, but it's okay. We will just simply use our law of exponents, same thing as I did before. So let's look at the inside first. If you look at the inside, I have cube root of 2a. So that simply means that I have 2a raised to the power of what? Well, both of these just have exponents of 1. So our numerator will be 1 over, that will be a denominator of 3. Now this whole thing, we're taking the 5th root of that, which simply means if this whole thing on the inside is an expression, it has a power of 1. So that'll be to the power of 1 over 5. Well, now this is using our law of exponent of power of a power rule. If you're taking the power of another power, what do? You simply multiply the powers together. So this is 2a to the power of 1/3 times 1/5, which is 2a to the power of 1 over 15. And now that we've simplified it and can't do anything more, we'll go back and rewrite this in radical notation, which means our index is 15. So we have the 15th root of 2a.